Gravity. It's the defining principle of physics here on Earth. It affects nearly everything in the universe and is precisely 9.80665 meters per second squared at sea level. It's also how your poop gets from your toilet to the wastewater treatment plant. Sewer systems are wonders of modern infrastructure. Back in the olden days, cities had open sewers where waste flowed through open canals on the streets. Today, we're much more civilized. We transport our waste underground in large pipes. Sewer systems are essential to modern plumbing. Every time you flush a toilet, use a sink, or take a shower, you create liquid waste of varying chemical makeups that has to be transported and treated. You could just flush it into a septic tank, but these tanks require maintenance and come with a host of other issues when integrated en masse for modern cities. We have to manage our waste because it stinks, it contains deadly bacteria, and it has dangerous chemicals that could affect the environment. You probably know that wastewater gets treated at a wastewater treatment plant, but let's take a look how it gets there. Sewer systems. Urban wastewater systems are needed in densely populated areas so you don't have to deal with your neighbor's waste. In ideal environments, sewer systems are completely gravity-fed, meaning that the pipes slope downward from the source, your toilet, to the wastewater treatment plant. This is done because wastewater has a lot of solids in it, making it harder to pump. Wastewater also has a lot of bacteria and chemicals, and when we push it through turbulent environments like pumps, it can create dangerous and deadly gases like hydrogen sulfide. In an ideal sewer system, pipes from each house or building flow into a sewer main that usually runs alongside a road or underneath one. The sewer main in a large area is usually 3 to 5 feet in diameter, with pipes from each house being about 6 to 12 inches in diameter on average. In every sewer main, there are periodical vertical pipes that meet the ground with manholes. These access points are spaced depending upon the local code and needed just in case a problem arises in the sewer main. Say your toddler has a nasty habit of flushing toys. If they do this enough and the toys make it into the main, there might eventually be a major clog that city workers need to remove. Sewer mains will flow into progressively larger and larger pipes as they accumulate more and more sewage, until eventually they reach a wastewater treatment plant. Usually, these plants are in low-lying areas to make engineers' jobs of designing sewer systems much easier. However, all of this gravity-fed sewer system talk is the ideal scenario. What happens when your house is below the elevation of the wastewater treatment plant, or if the sewage needs to travel over a hill? You need to pressurize the poop. This is done using grinder pumps or lift stations to pump the sewage up over hills. These stations collect sewage from lower elevations and utilize pumps to push it up to the needed height where it can gravity flow from there on out. These pumps are specifically designed to handle the high amount of solids seen in waste like toilet paper and flushable wipes. These pumping locations are usually in places of relatively low elevation due to their nature and will likely have a small building to house the equipment. They're also usually placed far away from human populations as they have a nasty habit of exploding, or at the very least producing dangerous levels of hydrogen sulfide due to the turbulent sewage. Sewer systems at their core are a bunch of sloped piped drains that take your waste from your house to a treatment plant. Occasionally there are pumps, but for the most part, gravity does all of the work.
Cities and towns have sewerage systems in place to carry the wastewater from our homes, hotels, factories, and other establishments to a sewerage treatment plant where the wastewater is treated. It is then deemed safe to release into other water sources. The treatment of wastewater goes through different stages. Wastewater is treated to remove the physical, chemical, and biological contaminants present in it through various processes. The pre-treatment process involves the sewage being sent through grids or vertical bars that can remove large solid substances like metal cans, paper, and plastic materials. In primary treatment process, the sewage flows through the grit chamber very slowly, so that the sand, pebbles, and soil settle down at the bottom. The sewage flows into the settling tank or sedimentation tank, where the solid wastes like feces are allowed to settle down. Wastes such as soaps, oils and grease rise to the top of the wastewater. The waste material that settles down at the bottom is called the sludge, and the floatable material is called the scum. Scum is then removed using a skimmer, and sludge is removed with a scraper every few days. The water that is left out is called the clarified water. In the secondary treatment process, biological or organic wastes are removed. It is a biological process. This is done by transferring the clarified water into an aeration tank, where air blowers bubble air, which helps the aerobic bacteria to grow and feed on the organic contaminants such as food waste, feces, and other organisms. The mixture then flows from the aeration tank into the clarifier, where activated sludge settles out by gravity. The activated sludge so produced, along with the sludge produced in the primary process, is transferred to the digester, where it is decomposed by anaerobic bacteria. Biogas is produced in this process, which can be used as fuel or can be used to produce electricity. The activated sludge is then left in the sand drying beds. Some quantity of water in the activated sludge evaporates, and the remaining quantity drains through the sand beds. This leaves behind the remaining dried sludge, which can be used for making fertilizers or compost. In the tertiary treatment process, the leftover wastewater is treated with chlorine to remove the phosphorus compounds, nitrogen compounds, and bacteria. It is a chemical process. Chlorine tablets are added to kill the germs. This process is called chlorination. Then this water is let off into the water bodies.
The sewage system in Nairobi continues to pose a threat to the city's ecosystem, from broken and open sewers to several tons of human and garbage waste flowing through the sewage lines. This, coupled with the frequent water shortages in especially low and middle income areas in the city, calling for a growing need to improve how we manage domestic and industrial waste generated every day. Ever wondered where the water and waste from your homes and sewer lines flow to? All the water supplied to the city for domestic and industrial use turns to wastewater and is collected through the sewerage system, which finally channels it to the treatment plants. The Ruai Sewage Treatment Plant, the largest wastewater treatment plant in Kenya, receives close to 80,000 cubic meters of wastewater, amounting to 80% of Nairobi's domestic and industrial waste. Wastewater treatment is defined as the process of removing contaminants from wastewater produced by both domestic and industrial sources to produce clean water that is suitable to discharge back into the environment.
We receive both domestic and industrial waste. For domestic is for the connected estates that are connected to our sewer lines, they discharge to our system. For the industries, they have to pre-treat their effluent first before they discharge to our system.
The wastewater collected is treated through a physical and biological process. At the first stage, large organic solids are removed both manually and mechanically. The water then flows naturally by gravity onto the biological facility, comprising of anaerobic, facultative and maturation ponds, where it is retained for further treatment. The treatment process takes 60 days to complete.
Bacteria activity is quite high at this stage. Yes. So the water retention periods from 5 to 10 days removes most of the organic wastes. So whatever settles at the bottom is what we call sludge. Yes. Sludge settles at the bottom. Then after 5 to 10 days, the water now is displaced by the incoming through the channels again to the other ponds, we call them the facultative ponds. They are the largest by size, but they are 1.7 meters deep.
All the ponds have been constructed in a way that they aid the application of biological treatment effectively, from the anaerobic bacteria used to work on the organic waste to the activation of facultative bacteria that eliminates majority of toxins and organisms. At the final stage of maturation, sunlight is able to penetrate to the bottom of the pond, killing pathogens through UV rays. In the ponds, organic particles are broken down to carbon dioxide and water, and non-biodegradable particles flow to the bottom to form a sludge. To test the effectiveness of wastewater treatment, catfish and mudfish are introduced into the maturation ponds.
In the last maturations, we've kept the mudfish and the catfish as our biological animals samples. Because if the system is not efficient, then they will not survive in it.
Aside from this being a sewage transplant station, it has potential for nature lovers to enjoy bird watching out of the 27 species of birds found at this location. The biological ponds have become a habitat for 27 species of birds, a proof of the efficiency of the water purification process, and provides a perfect opportunity for bird watching.
Very many people have never experienced bird watching. It's what made us to have a keen interest to create awareness to the local community and show them that bird watching, it is an interesting activity, and even we get very high-end tourists coming all the way from other parts of the world to come here and enjoy with us the bird watching.
The wastewater treatment, however, faces various challenges, including the dumping of non-biodegradable plastics and polythene bags. So next time you dispose of your solid waste, please exercise some measure of responsibility to ensure a cleaner environment.
Waste from London's toilets, sinks and gutters is carried away by a network of interconnecting ever larger pipes designed and built by sewage superstar and pioneer Joseph Bazalgette. It all ends up here, a sewage treatment works.
This is Beckton Sewage Treatment Works in the east of London, and it's Europe's biggest. It was originally part of Joseph Bazalgette's scheme, but I tell you what, sewage treatment has really moved on since his day.
In the 19th century, sewage was simply stored here in tanks, then pumped out to the river at high tide. So you'll be pleased to know today's process is a lot more refined and takes just 4 hours for raw sewage to be clean enough to return to the river.
Every day, this treatment works handles the sewage from 3.4 million Londoners. Now that's an astonishing volume. It equates to 34 Olympic swimming pools every hour.
So how does it treat the byproducts of our late-night beer sessions and trips to the local curry house?
The first process happens here at the inlet works. Using these screens, large lumps like bricks, wood, rags are raked out.
Once collected, these large objects will all be washed and sent to a landfill site nearby.
They've even had half a car here.
Meanwhile, the remaining sewage passes on to the next part of the process into these primary settlement tanks.
Now, very basically, it enters at that end and flows relatively slowly this way.
Over the top of each tank is a moving bridge, which has 2 blades to remove solid organic material from the sewage. The top blade skims scum from the surface, while a second submerged blade dredges the heavier settled sludge from the bottom of the tank. All this solid sludge is then sent for further processing.
The remaining sewage then flows down this way towards the secondary biological treatment process.
And here it is. In these tanks, the sewage is mixed in with billions upon billions of bacteria, so all the dissolved materials that still remain can be biodegraded.
And pumping air from below at very high pressures causes the sewage to be saturated with dissolved oxygen, and this accelerates the biological breakdown.
It's brilliant.
Finally, the treated effluent is tested to ensure it's clean enough to go back into the Thames. Meanwhile, remember all of the solids which were skimmed off earlier? They're taken to a processing plant.
All sludges are brought to this filter press where it's dewatered, and the resulting sludge cake is incinerated, and that provides 75% of this entire works' power needs.
Wastewater is treated to remove several substances which, if discharged to our rivers, lakes and seas, would cause pollution. This treated wastewater is a resource and can be recycled and used for irrigation in agriculture, parks and golf courses. It can also be used for street cleaning. The current scarcity of water and recurrent droughts have made wastewater treatment and recycling important elements in the sustainable management of water resources. In large cities, complex and highly technical processes are used to treat the wastewater. These conventional treatment plants are expensive and require a lot of energy. The wastewater passes through a series of sequential phases. These are called pre-treatment, primary, secondary, and tertiary treatment, where the pollutants are progressively removed from the wastewater. These processes allow the treated effluent to either be discharged into the environment or to be reused. For smaller populations, conventional treatment plants are often not suitable, since they constitute an expensive and a high energy-consuming process. However, constructed wetlands represent an ideal eco-friendly and sustainable technology with a low cost of operation, maintenance and energy. Constructed wetlands are simple wastewater treatment systems. They consist of shallow tanks filled with a gravel layer and planting with emergent rooted wetland plants, such as the common reed. These plants are well adapted to live in flooded conditions found in wetlands. As the wastewater flows through the gravel and the roots of the reeds, pollutants are progressively removed. Wetlands are constructed so that the wastewater flows below the gravel layer. This results in the absence of mosquitoes and bad odors. To observe the wastewater flowing through the constructed wetland, it is necessary to dig a hole in the gravel. This also allows us to observe the roots of the reeds. It is in this environment of roots and gravel that the wastewater is treated. Here, pollutants are removed by physical, chemical, and microbiological processes. The roots and gravel form a media ideally suitable for the growth of bacteria. It is these microorganisms which contribute most to pollutant removal. Constructed wetlands do not require as many components as conventional wastewater treatment plants. They require pre-treatment, a system for sedimentation of solids, and the wetland itself. Pre-treatment consists of screens to separate gross solids and plastics. These solids can easily cause obstructions, and thus it is best to separate them from the wastewater. After pretreatment, the wastewater flows to a septic tank where suspended solids are settled by gravity. After passage through the septic tank, the wastewater is partially clarified. As a final stage, the constructed wetland removes the remaining pollutants. Wastewater is fed to the wetlands by means of channels, therefore ensuring a uniform distribution throughout the bed. Water flows through the wetland and is finally collected by means of drainage pipes located at the bottom of the basin. Wetland effluent flows out through a swivel pipe that allows control of the water level in the wetland. The effluent from the wetland is very clear as all pollutants have been removed. Therefore, the effluent is suitable for water reuse or discharge into the environment.